Hey folks, welcome out there. Another afternoon, another week of Mathline, and we've had so much interesting things going on here this week. I'm Ernie Roberts. I'm here to host one more interesting day of the show, all right? And we're glad you've tuned in. Again, we welcome you to join us. And can you join us? You can give us a call, 844-686-2378. Always have a great show, but you know, when you folks call in, it makes the show rock. It really does. And we have a lot of fun with it also. What are we here for? If you call in that number, give us a math problem. We will be glad to work it out for you together, and we'll try to come to some sort of consensus solution that is reasonable, good, and what you're looking for, all right? But again, you got to make that call, 844-686-2378. Now, to prime the pump a little bit, let's go and look at what we call problem of the day. And this one looks like it's got a little length to it, my friends. There are 10 black socks and 15 brown socks in a drawer. If you grab 2 socks without looking, what is the chance you draw 2 black socks? Well, I brought some socks in here, all right? And honestly, this one is brown, this one is black, and honestly, I can't tell the difference. And if it's in the dark or you're waking up in the morning and you've just thrown them in there like that, you don't band them together, you know, like Mom used to do for them, all those kind of good stuff. Or you need to do for yourself, I guess, then. But anyhow, I get the idea. They're hard to tell. So you're reaching in. So the chance is, with this situation, with 10 black socks, let's take a look at it. 10 black socks and 15 brown socks. Obviously, one of them got lost in the dryer or under the bed or something because you got an odd number there, so you don't have a complete pair of brown socks. That's part of the fun on this problem. So what we're going to do is figure out, if you grab 2 socks without looking, that gives a randomness to this situation. What is the chance that you're going to draw 2 black socks? All right, we're ready. Everybody got yourselves on here, and there they are, the socks. Oh my goodness, I did not bring 25 socks with me, just 4. But let's see what happens here. First of all, it's a situation where we ask ourselves, if we get the black sock, are we going to put it back in and draw again? No, we're going to keep it. So this is a situation where we call it without replacement. So the probability is going to change for the second draw. So let's look at what's happening. We're looking at starting with 10 out of, well, how many socks have we got total? That's the first thing. It'd be 25 of those things. By the way, I want to give a shout out to Griffin for giving me this problem at the Episcopal School here in Knoxville. Appreciate it, and we're working through it for you, buddy. I hope you're watching today, all right? It's our problem of the day. So, hey, like I said, you send me a problem. Many times we can make it into a problem of the day if you do just right for us, okay? Now, what happens here? We have 10 chances, black socks out of 25. We draw 1. And the thing here is saying, basically, is setting up, what's the deal if we draw 2 black socks? Well, we actually draw them out together. We grab 2. But we've got 1. We know that it's black sock, all right? So that's our 10 chances out of 25. Now, what's the chance if that has happened? Okay, this is the big if. If that's what we have, and that's what we're looking at, that probability, what is the chance that the next sock will also be black? Well, we just took one of the black socks out of the mix. And we took out 1 sock from the whole big total mix. So here's what we're looking at. Here's our fractions. 10 out of 25 times 9 out of 24. And some of you are going like, whoa, big numbers, glass eyes, all that good stuff. You know, we're not happy with, ooh, that's kind of crazy. Folks, we can do some reducing here. Let's make this easy on ourselves, all right? And some of you say, well, we can just go on the calculator, can't we? Oh, let's do a little bit of math here, because a lot of our younger students, they're going to expect to reduce the fractions if they can. And here we go. Let's reduce. 10 out of 25 is going to give us 2/5. Does everybody see that? So what do? We divide both of those by 5. They end with a 0 and a 5, so that works great. How about the second fraction? Not quite as obvious, but yet there is something staring at me that I think we'll reduce. We can divide both of these by 3. The 9 by 3, the 24 by 3, and we're going to have 3/8. Now, folks, because they connect together, we multiply. If they had been, by the way, if we had put it back in there, we would just have 2/5 times 2/5 be done. Easy, all right? But what happened here, we had a little bit of an adjustment, but we're still multiplying. What are the chances of them working together? So we don't add them in this case, we multiply. And where are we going to go on this situation at this point? Well, I see a little bit more that we can do on the cancellation part with the fractions. Let's do that. Let's take a 2 into both of those on the diagonal. Remember, we can't go across, but we can certainly go diagonally. 1, and that'll leave us with 4. And my shot here is that we're getting 3 out of 20. And that would be, hey, those of you who like to do percents, that would be, as a decimal, it's 15/100 or 15%. Now, some of you are going to ask me, well, Ernie, if we had done 90, which that would be what we got, 25 times 24, I think would be 600. Would we have gotten back down to 15%? Believe so. You want to check real quick? Let's go for it. Let's see, I said 90. I hope I got my multiplication right. And we're going to divide that by 600. And my goodness, that is 1,500. So yes, we could have gone there. All right, we could have gone there. And when you are taking statistics classes and on up there, but you know, back in the good old arithmetic classes and getting ready for 6th grade, 7th grade, and Griffin was an 8th grader. He's an 8th grader at the Episcopal School, so this was basically a summer project he was working on, or summer problem he was looking at. So there you have it, my friends. 15%. You could use a decimal. You can also leave it as a fraction. All 3 good to go. And you could also do the multiplication, but I like simplifying and then multiplying. Makes the numbers a lot easier to work with. So there's your problem of the day. I hope you all got it. I noticed a lot of people are liking it on Facebook. It wasn't quite as, evidently quite as palatable today as some of our others have been. We've had a lot of good Facebook responses. I do want to give a shout out for yesterday's on the ice cream question. Sherry, Rhonda, Melody, and Melissa all came up with that $2 price for the new price on the ice cream. Good job on that. And we have some other likes and such there. Go ahead, my friends, when you like us on Facebook or like a problem on Facebook, go ahead and submit an answer. We always love it when we do that. And I will give you a like because you did it. And then I will also go back and explain it, or we'll have also post the solution up there with you that you can link to it on YouTube. So again, problem of the day, it's kind of fun for us. It's also a good way to break the ice and get us going. Now, what are we going to do? We need you to give us a call. That number, 844-686-2378. We've got an operator waiting for you to take the call. And you know what we want to do is hear from you. Give us some math problems to work with. I know we've gone through, many of you are just now getting back into the groove of school. May not have had much math to worry about. The easy stuff, it's review, what have you. But we're still here to help you out, all right? 844-686-2378. We definitely want to hear from you. And hear from you, we had an interesting hear from this summer. Had an email from a student named Alan Ray. Alan Ray says, well, what's so unique about that? Well, we figured out, the best we can tell is this came from the Philippine Islands, all right, from the Philippines. The question, this is what he gave me, sent me an email, and best we can figure out, everyone he knows and everyone out there, he's a young kid, seems to be in the Philippines. So anyway, Alan Ray, what happened? He said, well, how in the world would he hear it? Because this is Tennessee, right? We have it streamed. We are online. We are all over the place. So he said, I'm going to send something to him. We got the email address and sent the problem to us. So here we go. Let's take a look at this one. This one has a twist to it. Some of you go like, ooh, it's always twisted when you have a bunch of X's in there. Yeah, we got to figure out what it is. But when we get it, we're going to show that actually it is. By the way, the arithmetic mean simply means an average. All right? So we're going to find X. We want to find the value of X, and we're going to use that value to prove it out. And folks, while we're working on this, go ahead and give us a call, all right? 844-686-2378, so we can get you right in the funnel and get you ready to be asked here. Because, you know, this is our last live day this week, so you're going to have to wait until Monday if you don't get your answer today on your questions, on your problems. So be sure, give us a call, all right? And we'll take care of you on here, live on the air. That's how we work it out. If we can. If you can wait too late, we'll still talk with you. We'll work it out after the show. But you just won't get to voice your opinion and stuff on the air. So go for it, all right? Let's hear from you. Now, what are we going to do? We're going to take the let me call that arithmetic mean. I like to call it arithmetic mean. It's the average, okay? It's basically the average of these terms. Now, the first thing is we're going to say the average of x plus 2. Put it right there. Put a little parenthesis around it so we know what we got. And then we're going to add that to 4x plus 5. Now, the beauty of this situation is all these are positive, so it's going to be very easy to put them together in just a second. Now, what do? There are two terms. There are two numbers, we'll say here, all right? It's what we're representing. We're going to divide by 2. When we add these together, we'll divide by 2 and see what kind of interesting stuff we come up with. I'm not sure it's going to be as interesting as I'd like for it to be, but we'll figure out how to get around it. What is it equal to when we take these two, add them together? We're going to end up with this expression, 3x plus 2. Now, question is, where's this going to lead us? Where's this going to take us? All right, well, it's going to take us to adding these together in the numerator, because basically, again, this says do this. Then we'll divide at the very end here with the 2. And we get 5x plus 7. Now, all of a sudden, this doesn't look so bad. And we'll put a 2, keep that 2 underneath there. On this side, we've got 3x plus 2 hanging out. All right. Now, where's it going to take us? What's this going to do for us? Well, we need to get rid of that 2. And so you say, well, Ernie, you could divide 2 into both. Yeah, you could. But it's kind of nasty, those little fractions there. Let's see if we can't get this thing to come out a little bit nicer. You say, nicer? We like nice, don't we? All right, let's go for it. Let's multiply both sides by 2, because that's basically how we offset a 1/2. But if we multiply by 2, see they cancel? Everybody see that? You cancel. You got this working at home. But if you do it to the left side, you got to do it where? To the right side. That's the whole beauty of equations. So we'll put that 2 out there and say we're going to multiply it through. So say goodbye to those 2's, and let's do a distributive moment. I've got 5x plus 7 here on the left. On the right-hand side, I've got 2 times everything, which is going to give me 6x plus 4. I am thinking this looks pretty good, doesn't it? In fact, I'm thinking it looks so good, let's take it up here to the top and rewrite. How about it? 5x plus 7 equals 6x plus 4. All right. Now, what we need to do, we need to subtract 5x. And already this looks nicer because I took out that nasty-looking fraction, didn't I? By the way, does everybody know why I put that 2 down there? I think I mentioned it, but I want to make sure we understood. I have 1, 2 things in parentheses. I'm basically adding 2 numbers together to get their average, their arithmetic mean. I have to divide by the number of terms. It's not just because it's 2, but they're 2 terms, all right? So, no, it doesn't always come out to be 2 every time. If I had 3 of these to add together, guess what? We'd use divide by 3 and so forth. Back to the equation. I jump around a little bit, don't I? 7 equaling x plus 4. So we got 6x minus 5x. That gives us an x, all right? It's like having 6 of those. I took away 5. I still have an x, all right? And subtract that 4 over there. That one is going to be pretty easy. It looks like x equals 3. Now, that was the deal. It says find the value of x. Now, let's put a 3 in each of these spaces. Put a 3 there. Put a 3 here. And put a 3 here. All right? And let's see what our numbers are. At this point, I'm going to draw, not got much space left here. I'm going to put it right out here. We have 3 plus 2 gives us 5. We have 4 times 3. I believe that gives us 12. We all know that, right? Everybody got those multiplication facts down. Add 5, and that gives us 17. Now, what are we planning to do with those 2 numbers? We are planning to add them together and divide by 2. That's how we're going to check this thing. Now, you guys, and I hope we're all good at this, 5 plus 17, I see 22, and that's going to give me 11, okay? The question is, when I put a 3 here, drum roll, drum roll, drum roll, I get 3 times 3, which is 9, add 2, oh my goodness, 3 times 3, add 2, we also get 11. So it checks out, our answer x equals 3. And so many of these problems, we wonder, are there ways to finally make sure they check out completely, etc.? Yes, you can do very simple. Use substitution in this case and understand what are you looking for. You're looking for these 2 to add together, divide by 2. Should give you that result right there. So there you have it. Alan, Ray, if you are watching in the Philippines today, thank you. All right, we appreciate hearing from you. And now, folks, it's time for you who live in the state of Tennessee, who live in Kentucky, North Carolina, locally. Give us a call, all right? If they can send an email from out in the islands, we can hear from you guys on telephone, all right? And we'd love to work out your math problems here live on the air. That's what we're about today. Got about 10 more minutes of the show, so make it worth our time here, all right? We're here to help you. We're here to serve you. So Facebook, by the way, while we're at it, we've mentioned that a little bit here, and also the YouTube, but you can like us at www.facebook.com/Mathline online. Many of you are checking us out there this year, adults especially. But if you will, like us, love us, and above all, share us when you're there, all right? And we do appreciate when folks take care of us in that regard. I understand I have a caller waiting for me. Welcome to Mathline on this Thursday afternoon. Who am I talking with?
Charlie.
Charlie, how are you doing today?
Good.
Good. And where are you calling from?
I'm calling from Crossville.
Crossville. Well, great to have you with us on the show this afternoon. Well, what kind of problem have you got for me?
Oh, sir.
Yes.
What did you say?
What kind of problem have you got for me this afternoon?
Oh, okay. So open parentheses, 5.27 times 10 to the fourth power.
Okay, hold on.
And then
5.2
close parentheses
times 10 to the negative
plus,
4 power?
No, sir.
Okay, let's go back here. I got 5.2. Is that correct so far?
Yes, sir.
Times?
There's a 7.
Oh, gotcha.
5.27.
Thank you. And we're going to multiply by, is it 10 to the fourth or the negative 4?
To the fourth.
Okay, all right, there we go. Now, what we got next?
Close parentheses plus,
okay,
open parentheses, 5.27.
And what are we going to multiply that by?
Times 10 to the third power.
All right, 10 to the third power. Okay. Now, I'm going to tell you what I'm looking at this. This is basically, it looks like, it's almost like we call it a factor by grouping moment when we get into algebra there. But what you notice, there's a common piece to both of these, the 5.27. Does that make sense so far?
Yes,
sir. You see it in both places. And what we're going to do, we're going to pull them out. It's going to pull out. We're going to pretend it's almost like doing a distributive property, all right? And so what that is going to leave us with is this 5.27, and we're going to have them multiplied by 10 to the, we're going to leave it back here, all right, times 10 to the fourth plus 10 to the third. Now, and I'm going to put a parenthesis back in here, okay? Do you see where I've gotten that?
Yes, sir.
And what we can do here is make this as this value here. This is going to give us 10,000, I believe, right? 10 to the fourth, add a bunch of zeros. Going to give us 10,000. And we're going to add it to 1,000. You see where I got that? 10 to the fourth, 10
yes,
times
sir.
10 times 10. And then here we got 10 to the third. And this is one way of doing it. We can also just crank it head on, but I'm going to show you that I think this will work just as well. Let's work to our first of all, let's go ahead and put it down as 5.27, and I'm going to put 11,000 here, all right? And let's see what that gives us, okay? Does that make sense what we've done so far?
Yes, sir.
Okay, great. And it looks like we're going to get about 57,970. Now, I'm going to go just as if we were going to do the 5 and 27/100ths times, we're going to say times 10,000 because that's what 10 to the fourth is, correct?
Correct.
And then we're going to put a plus there. We're just going to crank it out just like we read it. And 527, let me go back there. Sorry, we need a decimal. Insert 27. And we're going to say times 1,000 because that's what 10 to the third is.
Yes, sir.
And we're going to press enter and hope that we get the same thing, which we do. So a couple of ways going back to our sheet here, guys. If we look there, we've got the option that we could have just cranked it out as you see it. And I think that's probably just as well because it's just basically wanting you to realize that you're multiplying by 1,000 here and you're multiplying by, 10,000 here and 1,000 there. But there's another way that we can go with it. We can see that we have that number in common, pull it out, and work it in that regard. So I don't know which way they're wanting you to go on that, but I think it's kind of basically we're pulling a reverse on the distributed property there. Okay? One thing I do want to mention to you, don't add this 4 and 3 there. Whatever you do, don't add the exponents. If there had been a multiplication symbol there, we'd go with it. So if you'd given me like times here, it would be a whole different story, a whole different ballgame. We would be adding those exponents and we would be worrying about what these numbers actually were multiplied together. Does it make sense? You see what I'm talking about?
Yes, sir.
All right. And again, we thank you for calling in on it. And like I said, there's a couple of ways you can look at to do it. Like I said, we can just type that thing in there and work it out, or we can work it in this manner. It gives us still the same value either way. And by the way, for those who are wondering, what's the final answer? Oh, yeah, 57,970. And we thank you so much for calling in today.
I have one other question.
Oh, sure. Yes, ma'am.
So what if instead, between the parentheses, if it was a subtraction?
If it had been a subtraction, well, all right. What would have happened if we had a subtract? You're talking about right here, correct? Everything would still be the same. We would still see 5.27 out here, okay? But here we would have 10 to the 4th minus 10 to the 3rd.
Okay.
And that would be, what, 10,000 minus 1,000. So see, everywhere we've had a plus, we would have been putting in a minus. So this would have ended up, you would have ended multiplying 5.27 times looks like 9,000. Rather than adding the 1,000, we would have subtracted. And obviously, you'd get a different answer. Does that make sense?
Yes, sir.
All right. And like I said, if there was a times there, which there could have been, then you would be worrying about multiplying these together as well as then adding these exponents. All right. That's a different rule there. But the way this is, basically, we can blast through it with either a common factor or just take it straight on. All right. Is that good?
Yes, sir.
Again, we thank you for calling in this afternoon. Appreciate that. Appreciate that. And folks, again, we've got a few more minutes here. You may try to give us a call, but you know what? It's almost the end of the week, and we've had a pretty good run on this first problem of the day that we had. Let's go back one more time on it, okay? And again, we had the point where we got to 16. That's what the calculator said. That's what we decided. And we've had a lot of discrepancy, a little bit of controversy over it. I want to show what would happen if we decided to get 1 for the answer, okay? Because a lot of you have just been saying, it's 1. It's got to be 1, Ernie. If we put a bracket here, and I'm pointing this out because in this day of technology, when we're using computers, we're using calculators to assemble answers and take things at face value. This is what happened when we got 2 plus 2. Life was good. But here the question is, what do we do with the 2? And the 2 is by division. The 2 is hooked to this by multiplication. But when it's hooked there, once these disappear, your parentheses is just simply going to become 8 divided by 2 times 4 in this day and age of technology. All right? Now, when we put this thing, we'll have 8 divided by 8. And that, dear friends, that gives you the difference. If you type both of those into the calculator, you will get a 16 just typing as such, and you will get a 1 if you put the brackets in there. So the brackets are important indicators. But anyway, thanks for all the commentary and all the fun we've had with that. I understand I have one more last caller. Let's see if we can get you in on the air. Welcome to Mathline. Who am I talking with?
Hey, it's Jake. How are you?
Yeah, I'm good. How are you doing? Where are you calling from today?
I'm calling in from Knoxville right now.
Knoxville. Awesome. What kind of, I know we've got just a minute or two, so if you'll hang, and I hope you've given your number our operator, I can get back to you if we're going to run out of time, I'm pretty sure. But what's your question for me? Let's see what we've got.
So with the 2 plus 2, what if you have an exponent with that parentheses?
Okay.
How would you be able to solve that? Just
go back to our original
say
problem
4.
here. Let me pull it back down here, guys. So you're telling me if I had 8 divided by 2 times what? 2 plus 2, and I put, let's say, a square on that?
Yeah, square.
Okay. Well, we would do the parenthesis, 8 divided by 2 times 4, and we would raise that 4 to the 2nd power.
Okay.
Because it goes parentheses, exponents, then we worry about this division and multiplication moment. But we're going to have, here's what's going on here. Now we've got this, once again, 8 divided by 2 times 16. So we would hit the division, then we'd multiply. Does that make sense to you?
Yeah, it makes sense. Thank you for
All
your help.
right. Hey, thank you. Good call to finish out the week. Folks, it's been great to get back with you here on Mathline this sixth season. Can you believe that? Let me tell you a little let me tell you a little about everything. Tomorrow we are going to start a Friday specialized segments for the month of August and September. We're going to look at trig, a right triangle trig from the standpoint of sine, cosine, and tangent. Those 3 buttons on the calculator, a lot of you go like, that's sin, that's cos, that's tan. Well, you know, tomorrow we're going to say, what is that all about? And we're going to work with it. Their ratios, their trig. I think you'll have fun with it. And we're going to be in a series on that. So those of you in geometry, algebra 2, or pre-calculus, it'll all be a good sign for you. And you know what? Most of you are going to get there by the end of your lifetime, right? So, hey, thanks for tuning in today, and we'll see you again next time.